Now we are moving towards the mathematics section. For the given orthogonal matrix Q, the inverse is. Now it is a direct question because it is given that the matrix is orthogonal, and for orthogonal matrix inverse is equal to transpose of matrix. So we have to just transpose the values. So our inverse matrix will be equal to transposed matrix. So first value 3 by 7, second value will be 2 by 7 here, third value 6 by 7, and so on. This value comes here, minus 6 by 7, then 3 by 7, then 2 by 7, then this value 2 by 7 moves toward this 2 by 7, then this value here 6 by 7, and finally same value minus 3 by 7. So this will be our inverse matrix. So correct answer would be 3 to 6, that is C option. The next question is, which one of the following matrices is singular? For singular matrix, determinant should be 0. So we have to just find the determinant of matrix. So determinant of first matrix is 2 into 3 6 minus 5 into 1 5 1. So it is not singular. Determinant of matrix B is 3 into 3 9 minus 2 into 4, that is 5. Next C, 6 into 2 12 minus 4 3 12 equal to 0. So it will be our answer, that is C option. The next question is, at the point x equal to 0, the function fx equal to x cube has local maximum, local minimum, both local maximum minimum, neither local maximum nor local minimum. Now at x equal to 0, the function has value equal to 0, and at x equal to just 0 minus, the value is negative, and at f function value at x equal to 0 plus, the value is positive. So our function has value 0 at 0, and at less than 0 it is negative, and at value greater than 0 it is positive. So the function is increasing, so it has neither minima nor maxima. So the correct answer would be D option. The next question is, the solution up to 3 decimal places at x equal to 1 of the differential equation d square y by dx square plus 2y by dx plus y equal to 0, subject to boundary condition y at 0 equal to 1 and dy by dx equal to 0, dy by dx at 0 equal to minus 1 is. So we have to solve this differential equation. So taking d by dx as differential parameter d, we can say it is d square y plus dy plus y equal to 1, which implies taking y common, d square plus, this is 2dy, so d square plus 2d plus 1 into y equal to 0, and d square plus 2d plus 1 is nothing but d plus 1 whole square y 0. So the roots of this equation is both roots same, that is minus 1. Since the roots are minus 1, we can take the complementary function as c1 plus c2x into e to the power minus x. Now this complementary function, for this complementary function we have two boundary conditions. So taking y as c1 plus c2x into e to the power minus x, we have two values, y at 0. So y at 0 will be putting x equal to 0, c1 plus c2 into 0 into e to the power minus 0. So it comes out to be c1, which is equal to, the value is 1. Similarly, dy by dx at 0 equal to, so dy by dx of this function will be, so differentiating c1 e to the power minus x, it will be minus c1 e to the power minus x. Differentiation of c2x e to the power minus x will be plus c2 e to the power minus x, keeping this constant and differentiating this. Further, keeping x constant, differentiating this, it will be minus c2 x e to the power minus x, and its value is given to us minus 1. So putting x equal to 0, this will be e to the power minus 0 1, so it is minus c1 into 1 plus e to the power minus 0 1, so c2 into 1, and here x equal to 0, so it will be 0 equal to minus 1. So from here we are getting c minus c1 plus c2 equal to minus 1. Since c1 is equal to 1, so from here minus 1 plus c2 will be minus 1, which implies c2 will be equal to 0. So the functions comes out to be, putting the values c1 1 and c2 0, 1 plus 0 into x e to the power minus x. So function is e to the power minus x. Now we have to find the value at x equal to 1. So y at x equal to 1 will be e to the power minus 1. So it comes out to be 0.368. So this will be our answer. The next question is the solution at x equal to 1, t equal to 1 of the partial differential equation del square u by del x square equal to 25 del square u by del t square subjected to initial conditions of u at 0 equal to 3x and del u by del t at 0 equal to 3 is. Now, so the given expression is a standard form of wave equation, and we know that in standard terms the equation is written as del square u by del x square into c square equal to del square u by del t square. So comparing the two equations, we can write del square u by del x square, taking 25 on LHS, so it will be 1 by 25 equal to del square u by del t square. So comparing, we get c square equal to 1 by 25, which implies c equal to 1 by 5. Now by D'Alembert's relation, this fx is 3x and gy is given to us as 3. Now applying the D'Alembert solution for wave equation, uxt will be equal to half of f of x plus ct plus f of x minus ct plus 1 by 2c integral gy dy with limits x minus ct to x plus ct. So putting the value, we will get function as half of fx is 3x. So f of x plus ct will be 3 into x plus ct. So x plus c is 1 by 5. So t by 5 plus 3 into x minus t by 5 plus 1 by 2c will be 5 by 2. Limits will be x minus t by 5 to x plus t by 5 and gy is 3. So 3 dy. So solving the relation, we get 3 into t by 5 and minus 3 into t by 5 will cancel out, and 3x plus 3x 6x by 2, so it will be 3x plus integral of dy will be y, and putting the values we will get 2t by 5, so it will be 5 by 2 into 3 into 2t by 5, so it comes out to be 3x plus 5 and 5 cancel out, 2 and 2, so it will be 3t. So final expression of u function is 3x plus 3t, and we have to determine the value at x equal to 1 and t equal to 1. So putting the values, 3 into 1 plus 3 into 1, that is 6. So our answer will be 6. The last question from mathematics portion is the value of the integral x cos square x dx with limits 0 to pi is. So our integral function is 0 to pi x cos square x dx. Now within the limits, applying the definite integral property, we can write the value of integral will be same if we replace x with pi minus x. So pi minus x cos square of pi minus x dx. Solving further, taking out the terms, so pi into cos square pi minus x dx integral 0 to pi minus x cos square pi minus x dx integral 0 to pi. Now again applying the definite integral property, we can write 0 to pi, taking pi common, pi minus x we can replace with x, so it is cos square x dx minus integral 0 to pi x into replacing pi minus x with x cos square x dx. So I equal to this term. Now this function is nothing but this value, so we are getting this as nothing but I only. So I is equal to pi integral 0 to pi cos square x dx minus I. So taking this I on LHS, we get 2i equal to pi integral 0 to pi cos square x dx. Now further, since it is symmetrical function about pi by 2, we can simplify it as 2i equal to half of pi into 0 to pi by 2 cos square x dx. So from here 2 and we should write it as 2 only. So here 2 and 2 will get cancelled out. We will get I equal to pi integral 0 to pi by 2 cos square x dx. Now we know that cos square theta is equal to 1 plus cos 2 theta by 2. So putting the values, pi, we are getting 2 function integral 0 to pi by 2 half dx plus integral 0 to pi by 2 cos 2x dx by cos 2x by 2 dx. Now integral of this will be x, putting the value, so we'll get half into pi by 2 minus 0 plus integration of cos 2x will be sin 2x by 2 and 2 and 2 will be 4, and putting the limits 0 to pi by 2. So solving, this will be pi by 4 plus putting the limits sin of 2 into pi by 2, that is sine pi will be 0 and sine of 0 will be again 0. So it is 0 minus 0. So we are getting value pi into pi by 4, that is pi square by 4. So the correct answer would be B option.